Hello, everyone. Now I'm going to talk about the extended list of basic indefinite integral. So in this section, I'm just going to present all the formulas that we have so far in that basic list of indefinite integral. Also, the basic property that we know so far that if you want to integrate AF plus BG, you're going to get A times big F plus B times big G. But it's possible that you're going to face those basic functions that do not have basic antiderivative, but for the moment being, we're just going to give you these formulas as just as a list, and you just have to learn how to use that list. And actually, in this course, that list will always be available to you. Like the goal of this course is to use antiderivative to do stuff. So this list will always be provided. Just a small remark here. So the first 12 bullets are the same as the one in section 2, where I gave you the list of basic formulas for computing indefinite integrals. But now there's 5 new ones that you need to learn how to use. First, the integral of tan is ln of the absolute value of secant of x plus c. The integral of cotan is ln of absolute value of sine of x plus c. The integral of secant is going to be ln of secant plus tangent plus c, and the integral of cosecant is equal to minus ln of cosecant plus cotangent, all that inside an absolute value inside the logarithmic term plus c. And one that I actually forgot, okay, so if you are computing the integral of any exponential function where the a value, okay, so it needs to be an exponential base, which means that it needs to be strictly positive and it cannot be 1. So any number strictly between 0 and 1 or strictly bigger than 1. So the integral of a to the power x is a to the power x divided by ln of a plus c. By the way, if a is equal to e, that formula works for ex. The integral of ex is ex over ln of e plus c, but ln of e is 1. Okay, so it works well in general. So again, this list will always be provided. You just need to learn to work with. So it's called extended because there's 5 more new formulas to work with, and the basic property is part of this list. So this is always going to be provided to you, like on a midterm or on a final exam. All right. So let's just do some examples quickly because they're just application of formulas. There's not too much. For example, the integral of 3 minus 2 sine plus 7 cosecant plus 2 tangent. So we know the integral of 3 is going to be 3x. The integral of sine is going to be minus cosine, so the integral of minus 2 sine is going to become 2 plus 2 cos of x. The integral of cosecant squared is minus cotangent, so you're going to get minus 7 cotangent. And now the integral of tan is ln of absolute value of secant. So if you have 2 of them, you just put 2, and then when you're done, you just go plus c. So another example, the integral of 10x5, the power is 5, so it's going to become 5 plus 1, which is 6. So you're going to get 10 times x to the power 6 over 6. The integral of cos is sine, so minus 3 cos will become minus 3 sine. The integral of 1 over x is ln of absolute value of x, so the integral of 7 over x is 7 ln of absolute value of x. And because the integral of cosecant is minus ln of the absolute value of cosecant plus cotangent, then the integral of plus 4 cosecant will be minus 4 ln of absolute value of cosecant plus cotangent plus c. And then one extra that is not in your note that I want you to add up. So let's integrate 2 times ex minus 5 times 2 to the x. So because the integral of ex is ex, the integral of 2 to the 2ex will be 2ex. But now because the integral of 2ex is 2ex divided by ln 2, the integral of 5 times 2 to the 2ex. Be careful, the 5 is not within the base here. So it's going to be 5 times 2 to the x over ln of 2 plus c. All right, so just more formulas that you need to plug in at the right spot if needed. But for that extended list section, okay, just learn how to use that list, okay, when needed, whenever needed. Okay, so, all right, that's it. That's all for basic stuff. Mwah. Ah, 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 ah.